what goes in the middleware layer. In this lesson, I am going to cover the middleware layer. This is the layer that hosts the key business logic of your application. The middleware layer is computer software that provides services to the software applications beyond those that are available from the operating system. This is the definition given by Wikipedia. Actually, this is in addition to what is expected from the system. So for an example, if you're building an online ticketing application where you're selling tickets for cinema halls online, so the core business logic, your web services, your microservices, or your plain vanilla business logic regarding this, that is deployed on the servers, is hosted on this, is basically this layer, middleware layer. Apart from this, there are additional services like security, transaction handling, logging, clustering, messaging that can be provided through this layer. Now, generally, these services are available through application servers. If you are using, Java application servers like WebLogic, WebSphere. So most of these middleware services are provided by the application servers or web servers, as I just said. These servers host your services or business logic that then talks to the source of data or database. So basically, essentially, this layer sits between your front end and back end. Your front end is the UI that the customer interacts with. Middleware layer hosts the key business logic or your algorithms, or all your search algorithms if you're building a search application, any specific business logic. So if you have a throttling API to throttle the users based on the number of requests they have, so all these validations and all will go in the middleware layer. And then you have the backend layer, which is essentially the database. Apart from hosting the custom code, these servers provide additional functionality like transaction support, security, etc. So in traditional Java web applications, middleware layer was built using Java software components earlier, like EJBs and web services, SOA services. More recently, microservices, as well as you can write, if it is a small application, you can just use Spring MVC as well. So how do you scale this middleware layer? There are certain best practices that you can follow to scale them. First is partitioning the middleware layer. So essentially, if a code is deployed on an application server, same code can be deployed on multiple other application servers, and then you can place a load balancer in front of it to just route the traffic, and this way you can handle multiple more requests. Stateless services. This is a key concept if you are replicating services across different machines. Why this is important is if you are holding state within your middleware layer, then if one server goes down and or if a particular request is sent to from a load balancer to one machine, then when that full session is not complete, at the same time another request through the load balancer for the same user goes to another machine, then if the state is held on the middleware layer, you need to synchronize the state across these two different machines, and that is a time consuming operation. It is like the state session replication has to happen across different machines. It is a very slow process. So to avoid this, stateless services should be used. So what basically this means is, still you need to store some state, right, across requests. So how do you do it? You will so hold the state on the client side in the form of cookies or hidden variables. Caching. So caching is another way to improve the performance of your middleware layer. So either you can use the caches, create a custom cache, using a singleton Java object or something, and host it on the application server itself. Or application servers themselves provide different forms of caching. You can use application context in terms of Java application servers, or you can use their session mechanism. You can use an external cache as well, and in conjunction with those provided by the application servers to enhance the performance of your application. Load balancers. This is a key technology that has to be used if you want to scale your system. You can use load balancers at multiple places. You can keep it in front of application servers, in front of web servers. You can keep load balancers in between your application server and databases. So if you have multiple instances of databases, you can keep a load balancer over there. There are different types of load balancers. You can study more about them in the reference section, like layer 7 load balancer, layer 4 load balancers. Read more about them in the reference sections. So this is an architecture of a typical scaled website. So if you see over here, this is a very simple architecture. It has a client that is sending a request to a load balancer. And then this load balancer, I have just used one load balancer here. You can have multiple load balancers as well to keep a backup of a load balancer. This load balancer is then sending the request based upon some algorithm that is set up over here. One example is round robin. So there are many other techniques that can be used. So it will send the request to a particular machine that has lower load, and essentially all these are application servers, and all these application servers have the same code deployed on them. So they might have stateless services hosted on them. And first they will send the request to cache to check if data is available in the cache. If it is not there in the cache, then the request goes to database and data is returned. This is a typical example of a simple enterprise application, and this is being done for maintaining scalability of the app. Okay. So middleware design patterns. The architecture shown earlier is just one of the middleware architecture patterns for a typical enterprise app. But for different kind of apps and for scalability, we can use different tried and tested middleware patterns. Some of the design patterns that I am covering here are not necessarily middleware patterns, but this is the best place to put them. That's why I'm putting them here. From the perspective of system design interviews, these patterns are very important. So enterprise applications and their app layer architecture styles. So entire application. So what essentially is an entire application? It's a traditional style of building an enterprise application where each tier is hosted on a physical box, and it's essentially one particular layer of the application. So functionality is broken into different tiers. Each tier resides on a physical box. Each tier can be separately scaled by putting multiple physical nodes of the same tier. So for example, the middleware is hosted on one box. You can keep multiple copies of the middleware layer. Thereby you can scale it horizontally. It helps in promoting loose coupling. The idea is if the UI of the application changes, you can just make the change to the UI and deploy it on its own separate box. So this won't affect the change to the middleware layer. It won't affect the changes to the database layer. So three-tier architecture is also an example of an entire architecture. So a three-tier architecture consists of a UI layer, a mid-tier layer, and a database. So loose coupling above causes UI to change without impacting mid-tier, as I mentioned earlier. So this is a typical example of a three-tier application. So here you have a UI layer, application layer, and data layer. Nowadays, this new form of architecture is becoming very popular: cloud plus containers plus microservices. So essentially, a microservice is a web service which is in its own individual functional unit. So it's a self-contained service. It is deployed on a container. So a container is basically, you can say, a hosted environment. So it is deployed, multiple containers can be deployed on single OS. So it is different from a virtual machine, and it is a self-contained unit of deployed infrastructure where a microservice can be deployed. The container itself can be deployed on a cloud, and then you can cloud like Cloud Foundry or AWS, and then you can manage these containers, like you can bring them up or you can close them through stuff like Kubernetes. It's a very popular model nowadays, and it is used across different big firms, like Netflix uses them and many other firms uses them. Event driven architecture. This is a very important form of architecture and it scales very well. So as the name suggests, you use some kind of messaging technology where events from a system are pushed. So if you want to collect data from different sources, for example, um, if you are collecting weather data or traffic data, for example, if you're collecting traffic data, say you have deployed IoT centers, IoT devices throughout the city to collect traffic data. So these IoT devices are pumping in data on a regular basis. And you have mobile devices where users can custom code and custom send a custom message regarding traffic updates. All this data can be pumped into an event bus, which is nothing but messaging technology. It can be an Apache Kafka queue, and you can just push the messages over there, and then there can be multiple consumers registered on top of these queues to read this data. And then once they read this data, they can pump it into other data sources where this data can be further analyzed. It's a very nice way of scaling your data at real time, and it's becoming very popular because Apache Kafka as a product is also becoming very popular. So there is another example that is mentioned here, which is also very important, and why event driven architecture is becoming popular. And that is, here I have given the example of Instagram. So when a user is uploading a photo, and there can be other users who are waiting to read this photo or picture, the upload usually takes a long time. So when an upload happens, if it is happening synchronously, the other people will be waiting at that point in time. So the way to architect this, one good way to architect this is to first break the services into upload service into an individual service, and then read service into a separate service. Then when an upload happens, at that time you can pump this upload request into a message queue, or into an Apache Kafka queue, or in some form of messaging queue, RapidMQ also you can use. So when the message goes into a queue, at that point in time the client is not held, not waiting for the server to send the response back. They can start doing some other activity because the message is already sent, and this is an asynchronous model. And eventually the consumers will start acting on these message and will take action, and will convert the image to a proper format, will store it, maybe store it in HDFS and send the response back, your image is uploaded properly. So this is a nice model in doing operations that causes the client to wait for a long time for an operation to take place. It also helps in scaling the system well. So this is an example of a diagram for event-driven architecture. So you can have event producers that are producing events, pumping them into event ingestion, and then there are some consumers registered to read data from event ingestion. So event ingestion can be a queue from where the event consumers are reading the message. So you can read more on this. There are these two resources mentioned here where you can get more information on this. One is on highscalability.com and also on microsoft.com. They have covered a lot of information on different architecture styles. Thank you.